As far as fire investigation, what we have is high pressure fuel lines that are exposed in certain places. Now there's low pressure fuel lines, which are these plastic ones. Some of them are under suction or very low pressure. But once we get into the fuel system closer to the injection, we'll notice that down here we have steel lines where my finger is pointing. Below here are steel lines that transfer high pressure fuel into the injection system. These lines are designed and manufactured to handle pressures above 30,000 psi, some higher than 35,000 psi. The issue being in a fire investigation is that the pump actions to reach those pressures create vibrations. If these vibrations allow the line to vibrate, which they do, the line can crack. Even though it's a robust steel piece of tubing, it could, and it does, produce a small crack, and a small crack in a line with 30,000 psi of fuel in it creates an aerosol within this engine compartment. So now we have this flammable aerosol inside the engine compartment while we're traveling down the road, and we have an alternator that produces sparks inches away. That is a mixture for a fire. Usually a fire like that will come with a report from the driver that all of a sudden there was just a big fire. That's something indicative of a flash of a fuel load within the engine compartment, like an aerosol built from fuel. The other thing that can happen in an engine compartment on the other side is that surfaces of the exhaust and the turbo, they can reach temperatures hot enough to ignite a thicker type of oil or fuel. It's not so much diesel fuel, but if there was a hydraulic oil from power steering or from engine oil or diesel fuel itself in more of a liquid form, if it was able to meet this surface, the vapors created from the evaporation of that can ignite from the temperatures of the surface. So in other words, the oil or fuel lands on the surface, it boils off and creates a vapor above it, and the vapor itself will ignite from the temperatures around it. That can happen readily on newer trucks, say past 2010, simply because they have an emission system called a doser valve. So one of these lines will carry diesel fuel into the exhaust and spray raw diesel fuel into the exhaust system. That means that we have a pressurized diesel line right in the same area as the exhaust. Now, many of these designs are very safe. They've been used on trucks since 2010. But if there is a mechanical activity, we had to remove the exhaust system or had to replace the turbo or do something around the exhaust that required the line to be removed, it's a possibility that it was not installed correctly, left loose, damaged, twisted, or bent, and down the road we develop a crack and the fuel drips onto the exhaust. We definitely will have a fire due to that, or even an oil, there's an oil feed to the turbo. If that leaks, again, engine oil will ignite on a hot surface like the turbo outlet. The third most common failure in an engine compartment that's going to cause a fire is electrical. Most electrical fires will occur around larger sources like the starter cables or the place where power is delivered to the power distribution center of the truck. So these cables are coming directly from the battery source. They go through very large fuses and they supply the cab with all the power required. Many of these cables prior to this fuse are not fused or protected and have the ability to chafe or rub or abrade anywhere on the engine compartment area and cause a fire. And the starter cables themselves are very large and they're confined within, you can see there's not much room in today's trucks. The aerodynamic design of the truck has compressed all the space in the engine compartment. and so cables have more opportunity for rubbing and abrasion and causing shorts. Those type of fires, believe it or not, generally happen after the truck is stopped, because now the cable has come to rest. It seems that when the truck is in action, the cables are bouncing. They may contact and release in a routine manner, but you know, in order to have a fire, we have to have heat for a duration of time. So once we stop the truck, whether we stop on the side of the road or we stop when we park it overnight, it seems the cables have more time to rest, create a connection, and cause a fire. So the one thing about engine compartment fires that originate around the starter area, and that's a very common area, they can be easily misunderstood as cab fires, because you can see much of the engine extends underneath the front of the cab. The starter is in this area. So if the fire starts in the starter area, it actually transfers through what we call the doghouse, which is this center large area of the dash panel, and enters the cab. So that type of pattern is easily misunderstood as a cab fire, where the trained investigator will definitely carry on his investigation further down below to see if the fire originated below the cab and entered the cab through the doghouse.